All right, let's get right into it. Today, we're going to pull back the curtain on data science and look at the absolute fundamentals, the core principles that make every single algorithm tick. Have you ever looked at a complex algorithm and just thought, how? It feels like magic, right? But it's not. It's really a language. And once you get the grammar of this secret language, you unlock a whole new way of seeing data. And where does this grammar come from? Well, you might be surprised. It comes from pure mathematics. Our guide for this journey is this amazing course material on mathematics for data science from IIT Madras. Now, here's the best part. This incredibly powerful language, it's built from just a handful of really simple ideas. Think of them like Legos, simple, powerful building blocks. You learn the blocks, you can build anything. So let's start at the very beginning. Let's talk about the most basic building blocks of them all, numbers and sets. Okay, so it all begins with the first numbers we ever learn, natural numbers. These are just your everyday counting numbers, 0, 1, 2, 3, and on and on. We use them to answer the most basic question, right? How many? How many pencils are on the desk? How many blueberries in the bowl? That's their job. And check this out. This visual is just perfect. It shows how number systems are built on top of each other, kind of like those Russian nesting dolls. You start with the small ones, the natural numbers, n. They fit right inside the integers, z, which add in all the negative numbers. And those fit inside the rationals, q. That's all your fractions. And all of that is tucked inside the real numbers, r. It's a beautiful way to see the idea of a proper subset. Each group is completely contained in the next one up. So if numbers are our raw material, our bricks, a set is the box we put them in. It's just a collection of things. But here's the crucial part, the one thing you really need to remember about sets. Order doesn't matter, and duplicates don't matter. So the set with 1, 2, and 3 is the exact same as the set with 3, 2, and 1. It's even the same as a set with 1, 1, 2, and 3. As long as the unique items are the same, the set is the same. Now, mathematicians have this super slick way to build new sets. It's called set comprehension, and it looks kind of scary, but I promise you it's just a simple 3-step recipe. First, you generate a bunch of numbers, say all the integers, then you filter them with a rule, like I only want the even ones. And finally, you transform what's left, maybe by squaring each number. Generate, filter, transform. That's the whole secret. Okay, so we have our building blocks, the numbers, and we have our containers for them, the sets. The next logical step is to start building connections between our sets. And for that, we use something called a relation. Here's the play-by-play. You start with two sets, let's call them A and B. Then you do this thing called the Cartesian product, which is just a fancy name for making all the possible pairs, taking one thing from A and one from B. A relation is then just any group of those pairs you decide to pick. That's it. That's how we formally draw a line connecting something from one set to another. And this quote from the source material just nails it. It's all about those ordered pairs. And that word, ordered, is key. The pair A, 1, is totally different from the pair 1A. This super simple idea is the bedrock for how we connect different pieces of data. All right, we've got our materials. We know how to connect them. Now we need an engine. We need a reliable machine that can do some real work for us. In the world of math and data, that engine is the function. So what makes a function so special? Well, it's a very specific kind of relation that has one single, absolutely critical rule. For every input you feed it, you get exactly one output back. Not 0 outputs, not 2 outputs, always, always 1. This predictability is everything. It's what makes building models possible. And this visual just makes it crystal clear. Look at the picture on the left. See how every single item in that first bubble has exactly one arrow pointing away from it? That's a function. Now look at the one on the right. See that input 1? It has 2 arrows coming out of it. It's trying to go to 2 different places at once. That breaks the rule. It's still a relation, for sure, but it is not a function. And when we talk about these function engines, there are just 2 key terms to know. The domain, that's just the set of all the things you're allowed to put into the machine. And the range, that's the set of all the things that can actually come out of it. Simple, right? Domain is the inputs, range is the outputs. So, numbers, sets, relations, functions. You might be sitting there thinking, okay, that's a nice math lesson, but what's the point? What does this have to do with actual data science? Well, it turns out it has everything to do with it. Let's translate this. Let's make this real. A set that's just your raw data. Think about the set of all your customers. A relation, that's what you do when you join two data sets together. You're creating a relation between your set of customers and, say, a set of all their past purchases. And the function? The function is the magic. That's your predictive model. It's the algorithm that takes one input, a customer's history, and produces one reliable output, the perfect product recommendation. See how it all connects? So the big takeaway is this. These aren't just abstract ideas from a math class. They are the literal grammar, the fundamental building blocks that are running under the hood of every recommendation engine, every financial model, every single piece of data analysis that's shaping our world right now. By understanding this grammar, you're not just looking at data anymore. You're actually learning how to speak its language. So I guess there's really only one question left to ask. Now that you know the language, what are you going to ask the data?